So welcome everyone to yet another PTC Talks, where we are excited today by having Jonas Fredriksson and Eric Kam from the ESI Group, who will be sharing their insights about weaving the digital thread through human-centric assembly line validation. Well, my name is Torbjörn Peterson, and I'm the Alliance Manager for PTC in the Nordics, and we are running all these webinars on Fridays every week, same time. But we also invite customers and partners for some inspiration on digital transformation to see what is possible and how to make things happen. And all the past webinars have also been recorded out to be found on the registration site. And the agenda for today is first a very quick overview of PTC by my colleague Carl from the customer success team. And then Jonas and Eric will run the show by introducing themselves, touch base on a few challenges, how to address these, and then explain some of the business outcomes. And at the end, we are also having a Q&A session, so please keep your questions to the end. Or you could also put them in the chat, and we will pick them up during the Q&A. So now over to you, Carl.
Yep, thank you, Torbjörn. So PTC is an international software company with headquarters based in Boston. We are developing software mainly for manufacturing companies since 1985. We offer tools for the digital transformations such as CAD for design, PLM for managing data, IoT to connect products and manufacturing operations, and augmented reality to visualize and interact with the digital thread. To you, Jonas.
Okay. Thank you, Carl, and thank you, Torbjörn. Happy to join the PTC Talks today. So a short intro on ESI Group before I hand over to Eric to talk about the subject of today. So ESI, we are a global software partner to support our customers' digital transformation. And when we do that, we are replacing virtual test, physical verification, physical prototypes with simulation and verification in order to deliver a safe, clean, and productive product, manufacturing process, as well as a service and maintenance organization. So we are based in 18 countries, around 1,000 employees, and this year we become 50 years. So we will have a big celebration this year. Next slide, Eric. So our story began then 50 years ago, and we started actually with crash simulation. So this is our roots and our DNA to replace physical crash with virtual crash, and we did it 85 with Volkswagen Polo. And Volkswagen is today one of our big and long-standing customers. And throughout the year, we have done several acquisitions in order to deliver a full virtual prototyping portfolio for selected domains. So let's go to the next slide, Eric. So with our portfolio, we talk about three different important things. We would like to be predictive. So with the crash simulation, the CIAT you see, we are able to do pre-certification of Euro NCAP, and our customers are able then to reach 5 stars without actually doing physical test. We also have the capabilities to support real-time. What Eric will show today is one part of real-time where you could interact with the design and 3D data in an immersed way. And this is also then bringing to the immersed. We also would like to secure that we onboard people and experience a virtual prototype in a very trustful way. And we also engaged in smart manufacturing. So what you see here also on the picture is casting simulation, where we, for example, are working on mega casting projects in the automotive industry. So supporting product performance, smart manufacturing, and what we will talk today about human product and process-centric validations is key for us. Next slide, Eric. And also to connect a little bit to why we are here today. Together with PTC, we are supporting Volvo Trucks. And we will also be present in LiveWorks to talk a little bit about this a little bit more. But this is an example how we are together enabling Volvo to actually experience the virtual data in a much better way and doing global collaboration to reach a clean, safe, and productive environment. So with that, I hand over to Eric, and then myself, Jonas Fredriksson, and I'm running the EMEA customer engagement organization.
All right, thank you for that lead in and that introduction, Jonas. As Jonas said, my name is Eric Kamm, and I am a product marketing manager for ESI Group, which we call our human-centric process validation tool. And that brings us to today's topic of unpacking or decompiling what I mean when I'm saying human-centric assembly. And what does it mean to weave a digital thread through that validation of human-centric assembly processes? And really what we want to do is we want to provide people with the necessary tools and the necessary insights that they need so they can have certainty that any new product that they are bringing to market, that they're in the middle of engineering, that you are kicking off its product life cycle, you want to have some certainty that people can safely and efficiently use those products, operate them, that they can build them, that they can assemble them, and that they're able to service and maintain those novel products. Because it certainly does not help any one of us if we're using the best-in-class CAD, PLM, digital testing software, if the products that we engineer, when we bring them up to market, end up not being useful or usable by the human operators, the human assembly people who are going to be working on that. And that's really our reason for talking about human-centric validation or human-centric processes. So kick this off. Let's first take a look at this generic idea of what does a product life cycle look like. When we think about the product development timeline, and what I have displayed on screen is maybe a relatively typical version of a 36-month or 3-year vehicle development program. And on the far left-hand side of the screen, you can see that young lady. Maybe she's a product engineer, product designer working on a new vehicle. Let's say that was an electric ground transportation, electric commercial trucking, as shown in the slides. And maybe at month 36 months before start of production, we're doing all digital engineering, digital product design, and everybody's living inside of their CAD and PLM or their digital mock-up environments. So it's not uncommon that the early decisions that we're making are all designed digitally and validated digitally. That progresses on until month 24, for example, when maybe that product design is released to the manufacturing engineering team so that they can start doing their due diligence to plan the manufacturing processes. And oftentimes, at the same time, the service or maintenance teams will also start their due diligence of planning their service procedures or their assembly procedures. Then we can see over in the middle of the slide, month 12 is maybe now when we start releasing that process plan data, the tooling design data, and that goes out to our vendors, that goes out to our internal suppliers, and maybe they start developing and delivering, realizing the physical tools and start stacking up our plan for that production line so that at month 0, we can start production stably. Now, one very important thing to notice as we transition from the left-hand side of that timeline to the right-hand side, as time marches forward, is that when we release that tooling or that product design data for the process planning, that product engineer, she's going to stop working on whatever that program was, and she's going to kick herself off on starting the next vehicle program. And then by the time that tooling is released for manufacturing to get ready for ramp up to start a production, then she might already be 2 or 3 vehicle programs further down the line than what is actively being built up in the assembly plant or in the tooling environment. And this is an important thing to note, because this is commonly where no matter what good software intention we have of maintaining a continuous and nonstop digital thread, that this is oftentimes where the digital thread gets broken. When people start building up those physical tools, they start finding things that maybe were not anticipated during the on-screen reviews of the digital data. And that might result in changes to the process, change to the product geometry or the tooling geometry that isn't always reflected in the CAD data or in our PLM or MPM data. And one of the challenges that we've seen and what we're trying to help you guys out in industry address is to partner with companies like PTC so that we can help you stitch back together and reweave any of those potential breaks in your digital thread. Now, to further elaborate on why that sometimes happens, let's first consider, when do we identify these issues? How do we identify them? And when is the earliest opportunity, once we find them, that we can resolve them or fix them? So again, I'm representing that timeline, kind of going across this chart on the left-hand side of the slide from left to right. We're in engineering, and every engineering program, hopefully, kicks off with a list of, this is what we found and this is what we learned the last time we engineered this part. Let's make sure we avoid those issues again. So they'll start off every engineer program with a list of frequently challenged issues, frequent problems that they had, and they'll try to resolve those as part of their due diligence of doing their product engineering. Hopefully, before they release that product design for process planning, they've resolved a majority of those issues and reached a steady state of, let's call it, no visible or no unanticipated issues. Then, as they start doing process planning, and maybe they're using computer simulation, maybe they're using their digital mock-up tools, and they emerge new risks. And again, part of that whole process of doing the tooling planning and the manufacturing planning is finding issues and then resolving them through design. And then at some point we reach data freeze, and we froze the data and we start stacking those tools up physically. And then we start encountering more risks or more things that we saw or issues that we found. And then after start of production, you see this big pile of new issues. And why do all these new issues arrive so late? And it turns out that when it comes to how human beings are going to interact with a software, or how human beings are going to interact with a new product. If this is a new first of a kind, one of a kind product, we don't necessarily have lots of experience of watching humans interact with them. And so there's quite often the first time that people can start interacting with a product and participating with it in a process is once those tools are physically available in the assembly line or in the manufacturing environment. And that means we've left a lot of remaining risk unanticipated and unaddressed, unmitigated until quite late in that process. When we talk about human-centric process validation, what we're talking about is trying to create new opportunities so that the humans can experience that product in the context of those human performed operations. So in the lower right-hand part of the screen, you can see I just put an image up there of two people in virtual reality doing an ergonomics review of the installation of a plug-in electric hybrid. That happens to be a Volkswagen Passat plug-in electric hybrid. And this team of manufacturing personnel represented by those ergonomics mannequins, they're trying to validate, the placement of that battery. And in doing so, by doing this in VR, they could quite possibly be performing this check much, much earlier than we normally would have people experience those physical processes. And by introducing the use of virtual reality or extended reality technology, we're providing the opportunity for people to effectively travel in time and teleport themselves into that production environment, that manufacturing line that has yet to be even commissioned. And they can start identifying and resolving those human factors or human-centric issues in their designs. And that way, we can really get involved and participate in the manufacturing processes before we finalize the product data and release it for process planning. We can identify how people will participate and experience that manufacturing process before we finalize that and realize that in hard tooling. And that's going to allow us to use this virtual build or this virtual reality human-centric process validation to really address that normally unaddressed risk that we would have to wait until serial production to arrive at. So that's what we mean when we say human-centric process validation. It's the fact that regardless of which technology we're talking about, there's still a ton of manufacturing operations and assembly that is still performed by people. Also, don't forget, service and maintenance processes, those also require human intervention, and the experience that an individual has while performing any one of these operations that you see depicted on the screen, whether it's me trying to service an APU of a fixed-wing commercial aircraft, whether I'm doing a subassembly of a plug-in hybrid power plant for an upcoming vehicle program, or if I'm placing batteries in the back of an electric wheel loader, those processes and experiencing those processes are very different conclusions that I would reach than what we could normally determine by doing deterministic simulation or some kind of simulated animation of a manufacturing process. So on screen right now, I have two things going on, so pardon me if the slide gets a little bit busy. But on the right-hand side, I have a series of engineering validations that I was performing in ESI Group. That is our human-centric process validation tool. And in these little bubbles around that animation, you can see things that I am looking for, or the necessary checks, the necessary validations that I would perform if in fact I was sitting in front of a real prototype or working in a real manufacturing environment. So what's happening on screen right now is I'm just validating what is the clearance that an operator can actually fit their hand in between, that's the headlamp of a passenger car and the rest of the body structure of that car. And what I'm trying to find out is, have we engineered that wiring harness with the right length and the right cable routing so that I can plug that in easily with the amount of room that I have to fit my hand in between the headlamp assembly and the rest of the car's structure. And in that little animated sequence, if I did find that the cable was too short, then I could, in the simulation, I could also engineer a longer cable and validate if that cable works. Now what's happening on screen is I'm seeing, does the operator have the necessary clearance to grab that cable and unplug it if it's already plugged in? Another thing that we might want to validate using this virtual reality to validate how humans participate in assembly. On screen right now is a colleague of mine, Meredith, and she's holding in her hand a physical headlamp from the previous model year. And we have that headlamp mounted with a virtual reality tracker, one of those things that we can get from Steam to accessorize my Vive or my valve index. And in this case, I'm doing a track simulation of me holding a physical headlamp so that I have a real weight in my hand and trying to mount that. So what we're able to do when we do this human-centric process validation is we provide for people an environment where they can validate things like product packaging and clearances, but in a much more dynamic and a much more immersive way than we would normally do if we were just using digital mock-ups and doing on-screen puppet shows. And so by making me involved or immersed in that operation of mounting the headlight, of trying to plug in that headlight, I am now an input. Me, the human being, is an input into that simulation and the decisions that I make as a result. So again, on screen, we just have another view, just a different part of that same vehicle that we had on screen just a moment ago. In this case, I have a variant. I have a left-hand drive and a right-hand drive variant of the same vehicle. And on screen right now, I just have a team of different stakeholders from my enterprise who are all taking turns just making sure how difficult is it to mount. That's the power brake booster for power brakes in the car. And I'm just making sure that if I'm mounting that in the left-hand drive, right, vehicle, will it mount just as easily in the right-hand drive? And we did make many discoveries that it is more difficult to assemble the right-hand drive car in regards to this brake booster. And it would increase that manufacturing lead time and slow down the takt time. So whenever we use these virtual reality experiences to validate manufacturing processes, some of you might ask, well, how did we capture that data, right? Where did that product data come from? So what's happening on screen right now is the output, the outcome of a couple of years of collaboration between ESI Group and PTC to integrate the wind chill, PLM, and MPM environment and integrate a data path into ESI Group. So first of all, on the screen, I'm going to back the video up just a little bit to go right back to the beginning, because this is important. Here we're taking product data that we've highlighted in the wind chill environment, and we pushed that data into ESI Group. And in doing so, I have effectively traveled almost a year or maybe 2 years forward in time to when that geometry of the product and the manufacturing environment would in fact be realized in the physical world. And on screen right now, I'm just taking that digital representation of the production process, and I'm just mapping that to overlay with what I know the physical environment of that plant's going to look like. Now what I'm doing is that you can see on the bottom of the screen, we have that little Gantt chart going across showing the process order or the procedural timeline, that Gantt chart. And we're trying to capture, is this an appropriate way to transfer that part from its staging area where it arrives from logistics to how it goes on the line? And maybe in this case, we know it in fact is not going to just travel in a straight line, but it's going to march 90 degrees perpendicular to that production line and then walk along that production line for some distance. And now that we've seen that on-screen puppeteering of validation, is that a reasonable process? Now one of my colleagues was able to put on his head-mounted display, or his HMD as we call it, and enter into that manufacturing environment and experience it for themselves. And so what we see on screen is that you'll see a little grayscale version of one of those components kind of flying across the manufacturing environment. And then my colleague walks over there after seeing that teleport from one point to the other, and then he goes over and picks up the actual part, has to physically, virtually carry it in his hands, and walks over to the line and mounts it to that the rest of that subassembly. And in doing so, he might recognize that the process was good or was well planned or was well defined or not. So if he did observe something that would require an engineering change, he's now added a process annotation, and he's quickly typing in on the screen. Don't worry about it. This is not an eye test, but we're capturing relevant data about what we saw in that well, let's call it a manufacturing validation of that mock-up of the assembly line. But what's important now is that he's captured that data digitally. And now that it's captured, we can submit that as a report, and that becomes part of the digital thread that gets transferred back into your wind chill, PLM, and MPM environment. And that way, we can reinstate, we can reconnect. What I said was that slight severing of the digital thread that often happens when we go from process planning to tooling realization. So there's a variety, there's quite a range of things that we can do in this virtual environment to provide you with opportunities to do things like validate this tooling. So in this case, I have an assist tool that's helping me pick up and lower a big tire for a large earth mover, a large wheel loader. And I'm validating, can I see where the tire gets mounted when I'm operating that? Because if I can't, maybe I have to re-engineer the tool. I have to make sure that this tool's not going to bump into my coworkers, not going to bump into the logistics racks, and is able to be an effective contributor to the manufacturing process. Another thing that's very important about what's possible in this human-centric validation is that if I'm already time traveling, I might as well spatially travel too. So on screen right now is a quick animation that I'm showing you, and I'm sorry for the bit rot of this video. It's a little bit choppy, but in that video, what's going on is that we had a collaborative session that pulled together our team from the US with our team down in Brazil. And the two of them, even though they're in separate countries and they're just completely different hemispheres, different continents, they are virtually standing in that same manufacturing plant together. And they're able to make experience-based decisions about, is this a plausible, acceptable process to me? Again, there's my colleagues from USA and Brazil trying to do the wiring of this electrical car, the plug-in electric hybrid. And then I'll have my colleagues from Sweden and Germany try to do the same thing. And this way we can involve so many more stakeholders in that human experience that they will be able to emerge and identify a lot of those manufacturability issues that normally would not be visible or even apparent to me until physical production. And that video is just refusing to run, so I'm just going to skip that one. So at this point, I guess the only question I have for you is, what are your questions at this time? Thank you very much for participating. And yeah, did I leave enough time for questions?
Yes, thanks a lot, Jonathan and Eric, for sharing those cool, really cool stuff here. So as I said, I mean, let's open up for the Q&A and any questions you might have here. So please go ahead, raise your hand. Otherwise, I have one, actually, the first question, and I was a little bit curious about, I mean, to see, I mean, which engine is actually used in generating these virtual reality animations?
Oh, yeah, I'm glad that you asked that. Couple things. First of all, those aren't just animations. Those are captures, real-time captures of what my teammates were doing with their digital avatars as they were building those vehicles or installing those parts. But the second part is that what you saw on screen is not coming from some sort of gaming engine or whatever. This is a direct conversion of the CAD geometry into the ICI-DO environment. So with ICI-DO, we're not reliant on using somebody else's renderer. We render all that geometry from whole using the CAD data, whichever CAD data that might be, and then just using that as the basis for your physical experiences and capturing them.
Right, thanks. And I had a follow-up question actually related, I mean, to this journey towards, I mean, the global collaborative reviews that you mentioned, and what are the next steps, I mean, going forward in the future? Could you elaborate a little bit on that?
Certainly. One of the things that was happening, like in those videos that I showed, when we saw the Germans and the Swedes and the Americans and the Brazilians collaborating together, in that environment, I had my workstation in my office, my colleagues had their workstations in their office, and we were doing a peer-to-peer review, sharing kind of like a multiplayer gaming environment between the two of us. Now, what we've been learning is that that's not always acceptable, where I have my computing resources that I carry around with me all the time. So we're seeing things like some of our customers planning to do 5G deployments where they create a centralized render resource that maybe they keep on site at their engineering campus, and they're streaming the virtual reality experiences to the workstations of the individual engineers and potentially to the conference room or to the validation hall, the pilot hall, where other stakeholders might be reviewing that engineering data. And so the next step really is moving it from this idea of individual computing resources that I carry around with me to now using a more centralized computer resource to further economize on the expenditures that my company makes for hardware and computer software.
All right, thanks. Also, I know, I mean, we normally have a lot of questions regarding, I mean, how do you actually, I mean, get started? I mean, what is who should get involved and where should you, I mean, normally focus on, I mean, getting started in any kind of, I mean, projects that you are normally engaged in? Any kind of recommendations on that?
Eric, maybe I answered that one before.
Yeah.
So I think what we have done with a lot of our, let's say, clients and customers work on is a workshop. So we go to a site, we do a 2 days workshop. It should be cross-functional. So we involve people from engineering, manufacturing, and service departments. It could be up to 20 people. And then we are doing some discovery works together. So how are you working today, and what are your, let's say, problems or let's say negative consequences of that? And if we were able to work in a different way, what would be the outcomes? How could we remove some physical tests? How could we secure that we don't get recalls, etc.? When we have gathered these use cases, we bring the data into ESI, and we prepare for the second day the possibility to experience this live. So in a 2 days lunch to lunch workshop, we are able to capture your needs, your challenges, document that, also imagine what is the positive outcome, and then also load your data and demonstrate that. So that's a super good way to actually build a business case together, and also for you to get an experience how this could help you and your organizations.
Yeah, that's brilliant. And one of the things also is that a lesson that we've learned as we've helped our customers deploy their virtual build engineering methodology, we have to also, people are trapped sometimes into thinking, oh, I need a VR expert for this ICI stuff. When in fact, what we really want is sometimes the people who were doing the physical mock-ups, the physical model making, those prototype makers themselves, they've been getting great benefit from learning ICI, which does take this whole virtual reality gamification, computer engineering aspect, and we've done that work so that we can have tooling experts and human factors experts and product design and manufacturing experts apply their expertise without having to learn how to make the VR happen. And that's one of the reasons that we focus on, distracting people from, it's not just VR, it's human-centric process validation. So who manages and who validate those human processes for you?
Right, thanks. So is there any, way, or is there any place where we could actually experience where you have just talked about?
Yeah. So myself and Eric, with some of our colleagues, will be present at LiveWorks in Boston. So you are more than happy to visit us in our ESI stand, and we will also partner up with PTC in the windshield demo area. So in these 2 areas, you have the possibility to meet us, speak with us, and also experience what Eric just talked about.
Fantastic. Sounds like a really fantastic opportunity, I think. So friends, time is unfortunately running out. So many thanks, of course, for all of you, joining, and a special thanks to you, Jonas and Eric, for sharing a lot of super cool stuff here. So hope to see you also back, already next week for the next PTC talks about solving a practical engineering problem with MATCAD by 9 altitudes. So with that, I hope you will have a fantastic weekend and hope to see you also at LiveWorks.
Thank you very much. It's been an absolute pleasure. Look forward to seeing the rest of you some other times.
Fantastic.
Take care.
Thanks, guys.
Bye-bye.